Good evening, student. So today MCQ test. This is your first question.
Sir,
Which
before
yes,
that,
okay.
good afternoon, schools and students. Today we are going to conduct 11th Physics MCQ test, and 3:30 to 4 o'clock we will conduct 8 questions and we will discuss the answers. Then from 4 o'clock onwards, few other schools will also get joined. 4 to 5 we will conduct 20 more questions MCQ. Hope you all the students are ready with your paper, pen, pencil and get ready. Teachers, the students who need assistance, please support them. Thank you. We will proceed, sir.
Okay, ma'am. Thanks, ma'am. Okay. Okay. So this is uh, your first question. Which of the following is a scalar quantity? Don't give the answer via the chat box. Write it on your paper. Please. First question. Which of the following is a scalar quantity? A. Velocity. B. Displacement. C. Distance. D. Acceleration.
We will wait for 1 minute and then we will move on to the second question, sir.
Second. Yes, sir. So each question, 1 minute only. Okay. I already started the timer. Please use that time effectively. Which of the following is a scalar quantity? Yes. Time is up. Okay. We will move into the second question. So this is the second question. A car travels 80 kilometer east and then 50 kilometer west. What is its displacement? In the for example, you have to mention direction also. So option A 130 kilometer east, option B 30 kilometer east, option C 30 kilometer west, and option D 130 kilometer west. Don't write only values, that is magnitude only. You have to mention the direction also, east or west. Okay, that is very important. I already started the timer. You have 1 minute. Okay, for each question. A car travels 80 kilometer east and then 50 kilometer west. What is its displacement? What is its displacement? All right, time is up. We will move into the third question. Now, okay, this is a third question. Speed is defined as option A, displacement divided by time. Option B, distance divided by time. Option C, change in velocity divided by time. And final D, rate of change of acceleration. You have to mention option also. For example, if the answer is B, you have to mention B, distance divided by time. Suppose option C. So C, and then you have to answer change in velocity divided by time. So you have to mention the option letter like A, B, C, D. You have 20 seconds left for this question. Okay, time is up. We will move into the next question, fourth question. If an object moves with a constant velocity, its acceleration. If an object moves with a constant velocity, its acceleration is option A, 0, option B, constant but not zero, non-zero, okay? C, increasing, D, decreasing. Option A, 0, option B, constant but non-zero, C, increasing, D, decreasing. Please do not type your answers in the chat box. Write down your answer on a paper, okay? Do not share any answer in the chat box, please. Okay, we'll move into the fifth question. So this is the fifth question. Which kinematic equation relates initial velocity, final velocity, acceleration, and displacement? Which kinematic equation relates initial velocity, final velocity, acceleration, and displacement? Option A, B is equal to U plus AT. Option B, S is equal to UT plus of AT square. Option C, V square is equal to U square plus 2AS. And then final D, S is equal to U plus V T by 2. You have to mention the kinematic equation which relates initial velocity, all the important terms, that is initial velocity, final velocity, acceleration, and displacement. Okay. So that kinematic equation which should contain that terms. Please do not type your answers in the chat box. Write down your answer in the paper. Okay.
Next question.
Now, okay. Yes. Okay. We will move into the next question. Sixth question. A ball is dropped from a height of 20 meter. How long does it take to reach the ground? G is equal to 10 meter per second square. Neglect air resistance. Actually, the value for G is 9.8 meter per second square. For simplicity, we can take G is equal to 10 meter per second square. Okay. Okay. So a ball dropped from a height of 20 meter. How long does it take to reach the ground? Option A, 1 second. Option B, 2 second. Option C, 3 second. Option D, 4 second. You have 20 seconds left. Okay. Time's up. Okay. We will move into the seventh question. The kinematic equation S is equal to ut plus of at square is used to find option A, velocity, option B, acceleration, option D, C, displacement, option D, time. The kinematic equation S is equal to ut plus of at square is used to find which quantity? Already I started timer. You have 30 seconds left for this question. Please do not write your answer in the chat box. Okay. Time's up. Okay. Now we will move into the next question. Final question. Eighth question. Okay. A projectile is launched with an initial velocity of 30 meter per second at an angle of 45 degree. What is its horizontal range? You can take G is equal to 10 meter per second square. Okay. A projectile is launched with an initial velocity at an angle, and then what is its horizontal range? Option A, 90 meter. Option B, 60 meter. Option C, 45 meter. Option D, 30 meter. Think about it that already you knew about the horizontal range. There is an equation for that horizontal range in the projectile motion topic. Yeah. So think about that. Okay. Time is up. Okay. Right. Okay. Let's check the answers. Okay. So first question, option C is the correct answer. First one, C. Second question, answer is B, option B. Third question, option B. Fourth one, option A is correct. Fourth one, option A is correct. Fifth question, option C is correct. Okay, correct answer C, option C. Option, okay. For the sixth question, option B. Seventh question, option C. For the eighth question, answer option A. Okay. Okay. Let's discuss the answers. First question, which of the following is a scalar quantity? So here, velocity, displacement, distance, acceleration. Already you knew about that scalar quantity. Scalar quantity is a quantity which has only value, that is magnitude only. So here velocity, displacement, acceleration, vector quantity, because it has value and directions. So C, option C is the correct answer for the first question. Okay, clear? Okay, good. Then second question. A car travels 80 kilometer east and then 50 kilometer west. What is its displacement? Suppose if you know the answer like that 130 or 30, but you have to mention the direction also. That is a very crucial point in that question. Yeah. Okay. So displacement is the net change in position vector. Yeah. So here you can take east is a positive and west is negative, because which is opposite to that previous one. Yeah. East and west. So east is positive, west is negative. So here total displacement. A car travels 80 kilometer east and then 50 kilometer west, means it travels in the negative direction, opposite to the east direction. So minus 50 kilometer. You have to put minus sign because opposite, because west is negative. Okay. So 80 kilometer east and minus 50 kilometer west. So 80 minus 50, 30 kilometer. So 30 kilometer east, because that car travels in the direction of in the direction east direction. Okay. So 30 kilometer east. So this is the correct answer. So option B is correct. Suppose if you write that 30 kilometer west, it is wrong. Okay. It is wrong. So east is the correct answer. Okay. Right. For the third question, very easy question. Speed is defined as the distance divided by time. Yeah. Velocity is defined as the displacement time. But here speed. So speed is distance divided by time. Change in velocity divided by time means acceleration. Okay. Change in velocity divided by time gives acceleration. Rate of change of acceleration is nothing but it is related to the momentum. Okay. Right. Now, fourth question. If an object moves with constant velocity, its acceleration is. So acceleration means changing velocity. Yeah. Suppose if an object or person moves with a constant velocity, the velocity does not change. Yeah. So acceleration is zero. Acceleration is zero. Okay. Clear? Option A is correct for the fourth question. Option A is correct. Fifth question. Which kinematic equation relates initial velocity, final velocity, acceleration and displacement. Here also v is equal to u plus at is one of the equation. Yeah, in the kinematic equation, and s is equal to u2 plus half a is another one equation. S is equal to u plus v into t by 2 is the another form of the equation in the kinematic equation. But you have to mention, you have to relate the initial velocity, final velocity, acceleration and displacement. So option C is correct. Here v final velocity, u initial velocity, a acceleration, s displacement. Clear? V square is equal to u square plus 2as. Clear? And sixth question, very important one. A ball is dropped from a height of 20 meter. How long does it take to reach the ground? Use the kinematic equation. That is, S is equal to ut plus half at square. Yeah? Okay. Here, u is equal to 0 meter per second because of the object dropped from a height. That means it is at rest in the initial position at the initial time. Yeah. So you have to put 0 meter per second for the initial velocity. So u is equal to 0 meter per second. And the ball is dropped from a height. Height means distance. Yeah. So distance, S is equal to 20 meter. And A or G, as I said, due to gravity, here G is equal to 10 meter per second square. You have to put all those values in the equation. S is equal to u2 plus half 80 squares. So here S is equal to 20, U 0. So 0 into anything 0. So here 0. And half 80 square. A here 10 and t square time. You have to find the time to reach the ground. So here t square only. Okay, right. So 20 half into 10. So 5 t square. Yeah. So t square is equal to 20 by 5, which gives 4. So t square is equal to 4. For the t, you have to take the root. Yes. From t square to t, you have to take the root. So root of 4 gives 2. Okay. So second means SI unit for time. So time t is equal to 2 seconds. So a ball is dropped from a height of 20 meter. How long does it take to reach the ground? It is 2 seconds. For the G is equal to 10 meter per second square. Okay. Clear? Okay. 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 Very slow. Okay. Right. So here use the kinematic equation. S is equal to ut plus half at square. U means 0 meter per second because of the object is at rest in the initial position or at the initial time. That's only we have to put u is equal to 0. Here the height. So height means distance also. Yeah. So S is equal to 20 meter. And as well as acceleration due to gravity or acceleration A is or equal to G which is equal to 10 meter per second square. So you have to put all those values in that equation. S is equal to ut plus half at square. U 0. So 0 into anything 0. Half at square. Half into A 10 and t square. You have to find the time. Okay. So 20 equal to half into 10, which gives 5. So 20 equal to 5 t square. T square equal to 20 divided by 5. Yeah, the 5 goes here and divided the 20. Okay, so 20 by 5, which gives 4. 4. T square equal to 4. So t equal to root of 4. 2. And t is equal to 2 seconds. Clear? Okay. Seventh question. the kinematic equation S is equal to ut plus half AT is used to find. Already I told you S means displacement. So the kinematic equation S is equal to ut plus half AT is used to find displacement. Okay. S means displacement or height or distance like that. Okay. Right. Eighth question. A projectile is launched with an initial velocity 30 meter per second at an angle of 45 degree. What is its horizontal range? G is equal to 10 meter per second square. Okay. Okay. Here we have a formula for range. Yeah. R is equal to U square sine 2 theta by G in the projectile motion topic. Yeah. Already you know that. So R is equal to range formula. Okay. R is equal to U square sine 2 theta by G. So U means initial velocity. So here you can see that initial velocity 30 meter per second. Yeah. That's why I am putting U is equal to 30 meter per second. Okay. At an angle of 45 degree. So theta is equal to 45 degree. Sine 90. Sine 90 1. Okay. Because in that sine 2 theta, you have to put sine 2 into 45 because theta is equal to 45. So 2 into 45, 90. That's why I am writing sine 90 here. Sine 90 means 1, the value 1, okay? Right? And G equal to 10 meter per second square. So put that value in the range formula. R is equal to U square sine 2 theta by G. R equal to U square 30 square sine 2 theta. So sine 90 degree 1. So 1 divided by G 10. Okay, clear? Clear? Okay. So 30 degree, 30 square, which gives 900. Yeah. Divided by 10. Divided by 10. So 900 divided by 10, which gives 90. So range means which is distance. Yeah. So meter. SI unit for distance, meter. So range is equal to 90 meter. Clear? So option A is correct for that question 8. Okay. Right. If you have any questions or doubt, please ask me. Please use the
Sir,
chat. Yes, madam.
we can start the next session, sir. It's
Okay,
already
madam.
full. Yeah,
Oh, clear. Okay, done, madam.
the
Thanks.
20 questions.
Okay. Once again. Okay. So today, physics MCQ test. Already you know about that. So here are the questions. First question, which of the following is a vector quantity? Which of the following is a vector quantity? For each question, you have 1 minute. Okay. Which of the following is a vector quantity? Please do not write your answer in the chat box. You have to answer on the paper. Okay. Don't write your answer the chat box. Write down your answers on the paper. Okay. Okay. We will move into the next question. Time's up. Okay. So this is the second question. Two vectors of magnitudes 3 Newton and 4 Newton act at an angle of 60° to each other. What is the magnitude of their resultant? A. 5 Newton, B. 6 Newton, C. Root of 90 Newton, option D. Root of 31 Newton. Okay. Timer on now. Two vectors of magnitude 3 Newton and 4 Newton act on an angle of 60° to each other. What is the magnitude of their resultant? Please do not write your answer in the chat box. Please write down your answers on the paper. Okay. So for this question, 30 seconds left. So come on, quick. Okay. You have 10 seconds left. Yeah, time is up. Okay, we will move on to the third question. Third question, the resultant of two vectors can be found using option A, simple arithmetic addition, option B, vector addition, that is a parallelogram law, C, scalar multiplication, and option D, division of magnitudes. The resultant of two vectors can be found using which one is correct? Which one is correct? Option A or option B or option C? Option D. So you have 30 seconds left for this question. For each question, you have 1 minute, okay, to answer. So for this question, 10 seconds left. Okay, time's up. Okay, we will move into the fourth question. In projectile motion, the horizontal component of velocity. Very easy question. Yeah. Yes. Option A increases with time. Option B decreases with time. Option C remains constant. Option D becomes zero. In projectile motion, the horizontal component of velocity is okay. We will move into the next question, fifth question. Okay, right. Fifth question. The trajectory of a projectile launched at an angle is the trajectory of a projectile launched at an angle is straight line, parabola, circle, ellipse. The trajectory of a projectile, straight line or parabola or circle, ellipse. Okay. Okay. We will move into the next question. Okay. Okay. Sixth question. This is the sixth question. The time of flight of a projectile launched at an angle theta with initial velocity u is time of flight. A is equal to, option A, u sin theta by g. Option B, 2u sin theta by g. Option C, u cos theta by g. Option D, 2u cos theta by g. So the time of flight of a projectile, already you know that formula, yeah? Time of flight. So you have 40 seconds left for this question. Please do not write your answer in the chat box. Write down your answer on the paper. You have 15 seconds left. Okay, good. We will move into the seventh question. The maximum height of a projectile is given by another one question that is related to the projectile motion. The maximum height of the projectile is given by option A, u square sin square theta by 2g. Option B, u square cos square theta by 2g. Option C, u sin theta by g. Option D, u square sin theta by g. Okay. Which one is correct? The maximum height, formula for maximum height. You have 18 seconds left for this question. Okay, time's up. Eighth question. A block of mass 5 kg is at rest on a frictionless surface. A force of 20 Newton is applied for 3 seconds. What is the final velocity of the block? A block of mass 5 kg rest on a frictionless surface, 20 Newton applied for 3 seconds. Then what is the final velocity of the block? 4 meter per second, 12 meter per second, 8 meter per second, 20 meter per second. You have 50 seconds left. Think about that. The formula for final velocity, which relates the force, mass. You have 19 seconds left for this question to answer. Okay. All right. Time's up. So we will move to the ninth question. Momentum of a system is conserved when A, external forces are zero, B, acceleration is constant, C, velocity is zero, option D, internal forces are zero. the momentum of system is conserved when 30 seconds left. Nine seconds left. Okay. Okay. We will move to the 10th question. A 10 kg object accelerates from rest to velocity of 5 meter per second in 2 seconds. What is the net force acting on it? Option A, 25 Newton. Option B, 50 Newton. Option C, 75 Newton. Option D, 100 Newton. A 10 kg object accelerates from rest to velocity of 5 meter per second in 2 seconds. What is the net force? Already I started the timer. Forty seconds left. Sorry, 20 seconds left. Ten seconds left. All right, time's up. Okay, we will move to the 11th question. Two objects of masses 2 kg and 3 kg moving at 4 meter per second and 2 meter per second respectively in opposite directions collide elastically. What is the total momentum before collision? You have to find the total momentum before collision. Okay. So A 10 kg meter per second, B 2 kg meter per second, C 14 kilogram meter per second. Option D 0 kg meter per second. Think about that. Already you know about that formula for momentum. Yeah. In elastic collision, you have to find that total momentum. Thirty seconds left. 30 seconds. We will discuss the answer in the final. Okay. Okay. Time's up. We will move into the 12th question. Mechanical energy is conserved in which type of collision? Mechanical energy. Already you know about that mechanical energy. That is potential energy plus kinetic energy. Yeah. So mechanical energy is conserved in which type of collision? Elastic collision, inelastic collision, plastic collision. Option D, all collisions. 10 seconds left. Okay. Okay. Time's up. Okay. We will move into the 13th question. Very easy question. The formula for gravitational potential energy is half mv square mgh mb ma. The formula for gravitational potential energy half mv square mgh mb ma. 30 seconds left. Okay. All right. Time's up. Okay. Fourth question. Sorry, 14th question. A 2 kg object is lifted to a height of 5 meter and then released. What is kinetic energy just before hitting the ground? You can take G is equal to 10 meter per second square. Assume no air resistance. Option A 50 joule. Option B 100 joule. Option C 150 joule. Option D 200 joule. A 2 kg object is lifted to a height of 5 meter and then released. What is its kinetic energy before hitting the ground? You have 40 seconds left. Okay. 10 seconds left. All right. Time's up. So 15th question. A 1 kg object moving at 6 meter per second collides elastically with a 2 kg object moving at 3 meter per second in the same direction. What is the final velocity of the 1 kg object? Option A 2 meter per second. Option B 0 meter per second. Option C minus 2 meter per second. Option D 4 meter per second. A 1 kg object moving at 6 meter per second collides elastically with a 2 kg object moving at 3 meter per second in the same direction. The 1 kg object, mass 6 meter per second, velocity collides elastically with another one object 2 kg, which is moving at 3 meter per second in the same direction. What is the final velocity of the 1 kg object? You have 15 seconds left. All right, time's up. 16th question. Very easy one. Kinetic energy is conserved in which type of collision? Kinetic energy is conserved in which type of collision? Elastic collision, inelastic collision, perfectly inelastic collision. Option D, all types of collisions. Okay, right? You go 5 seconds left. Yeah, okay, all right. Time's up. So 17th question. The coefficient of restriction for an elastic collision is option A 0, option B 1, option C greater than 1, option D less than 0. The coefficient of restriction for an elastic collision. You have 30 seconds left. The coefficient of restriction of for an elastic collision. Ten seconds left for this question. All right. Okay. Now we will move into the 18th question. A particle is projected with an initial velocity 20 meter per second at an angle of 45 degree to the horizontal. What is the range of the projectile? G is equal to 10 meter per second square. Option A 20 meter, option B 40 meter, option C 60 meter, option D 80 meter. A particle is projected with an initial velocity 20 meter per second at an angle 45 degree to the horizontal. And what is the range of the projectile? Range. Already you know that formula for range. Yeah. So put that formula and substitute the values in the equations and you will get the answer. Range. Ten seconds left. Okay. 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 Time's up. And 19th question. A 4 kg object is moving with a velocity of 5 meter per second. What is its kinetic energy? 25 joule, 50 joule, 100 joule, 200 joule. A 4 kg object is moving with velocity 5 meter per second. What is its kinetic energy? You have 15 seconds left for this question. All right, time's up. And the final question, 20th question. Yeah, two forces of 10 Newton and 15 Newton acts on an object at an angle of 90 degree to each other. What is the magnitude of the resultant force? What is the magnitude of the resultant force? Two forces, 10 Newton, 15 Newton, acts on an object at an angle of 90 degree to each other. What is the magnitude of the resultant force? You have 35 seconds left. Two forces. So option A, 5 Newton, option B, 12.5 Newton, option C, 18.03 Newton, option D, 25 Newton. You have 19 seconds left for this question. Okay, all right, time's up. Let's check the answers now. Okay, right. First question, option C is correct. Answer is option C. Second question, option B is correct. Second question, option B is correct. Third question, option B is correct. Fourth question, option C is correct. Answer. Okay. For the fifth question, option B. And also for sixth question, also B. Option B. Correct. Option B. Seventh question, option A. Seventh question, option A. Eighth question, option B. Ninth question, option A. Ninth question, option A. 10th question, option A. Okay. 11th question, option B. 12th question, option B. Okay. 13th, option B. 14th, option B. 15th, option A. 16th, option A. 17th, option B. 18th question, option B. 19th, option B. And the final question, 20, C, option C is correct. Okay. Clear? Okay. So let's discuss the answers. Okay. Right. Which of the following is a vector quantity? Vector quantity. So vector means it should have a value with the direction. Yeah. Speed, mass, energy. This is a scalar quantity. So here force. It has value and direction. So vector quantity is option C is correct. Force. Second question. The two vectors of magnitude 3n Newton, 4n Newton acts at an angle 60 degree to each other. What is the magnitude of the resultant? So resultant formula already you know that R is equal to root of a square plus b square plus 2ab cos theta. Here a 3 Newton, b 4 Newton, angle theta 60 degree. So cos 60 0.5 already you know that. So theta 60 degree. So you have to put those values in that equation. So root of 3 square plus 4 square plus 2 into 3 into 4 and then cos 60 degree 0.5. Clear? Okay. Clear? So root 3 gives 9, 3 square 9, 4 square 16, 2 into 3 into 4 into 0.5 which gives 12. So root of 9 plus 16 plus 12 which gives root of 37. You have to take the root of 37. So the value approximately 6.082 Newton. Yeah, 0 point. So in that option B is very close to the answer. Yeah. So we can choose the option B. Option B, 6 Newton. Okay. So here also you can see that approximately 6.08 Newton. So you can choose the option B. Okay. Third question, the resultant of two vectors can be found using, you cannot use a simple arithmetic addition for that vectors addition. Yeah. So already I told you that is vector addition. That is parallelogram law. This is the answer for the third question. Fourth question. In a projectile motion, the horizontal velocity, that is horizontal component of velocity, remains constant because in projectile motion, no horizontal force act. We can neglect the air resistance. So ignoring air resistance. So the horizontal velocity remains constant. Only vertical velocity will be changed. Yeah. So horizontal velocity remains constant in the projectile motion. Clear? Okay. And then fifth question. Okay. Fifth question. So here, the trajectory of the projectile lands at an angle. Already you know that parabola. Yeah, option B is correct. A projectile's path under gravity is a parabola because we can assume that no other forces, only gravitational forces acting on that object, projectile. So the projectile path under gravity is a parabola. Clear? Okay, good. Sixth question. The time of flight of the projectile lands at an angle theta with the initial velocity u is. Already knew about that formula, time of flight. 2u sin theta by g. Yes, 2u sin theta. 2u sin theta by g. For the sixth question. Okay, sixth question. Okay, 2u sin theta by g. Clear? Okay, right. Seventh question. The maximum height of a projectile is given by the formula for maximum height u square sin square theta by 2g. So option A is correct. Yeah, the maximum height of the projectile h max equal to u square sin square theta by 2g. Clear? Clear? Okay, right. Eighth question. A block of mass 5 kg is at rest on a frictionless surface. A force of 20 Newton applied for 3 seconds. What is the final velocity of the block? Okay. So use Newton's second law. That is F is equal to ma. F is equal to ma. Yeah. A equal to F by m. Clear? Here F means force 20 Newton. So 20 Newton. M mass 5 kg. So 20 by 5, 4. 4 meter per second square, which is a acceleration. But we have to find the velocity. So use that kinematic equation. V equal to U plus AT. Here U means initial velocity. But here a block of mass is at rest. So its initial velocity is 0. So U is equal to 0. A into T. A is 4 and T 3 seconds. The force 20 Newton applied for 3 seconds. So you have to put that 3 in that place of time. So 0 plus 4.3 gives 12 meter per second. 12 meter per second. Okay, clear? Okay, nice. Ninth question. The momentum of a system is considered when external forces are 0. Already very easy question. Yeah. So external forces, if the external force are acting on the system, that system momentum will change. So the momentum of system is conserved. That means remains constant when external forces are 0 or net force is 0. Okay, clear. Yeah, option A is correct. Option B. Question number 10. A 10 kg object accelerates from rest to velocity of 5 meter per second in 2 seconds. What is the net force acting on it? A 10 kg object. So M 10 kg, which are accelerate from rest to velocity. So rest means initial velocity 0, final velocity 5 meter per second in 2 seconds. So time is 2. What is the net force? So you have to find the force. So A is equal to, from the kinematic equation, we can choose that formula. That is A is equal to B minus U by T. Yeah. So because from the acceleration equation, acceleration is changing velocity by time. So changing velocity means final velocity minus initial velocity. So final velocity V minus initial velocity U. So V minus U by T. V final velocity 5 here and U rest. So you have to put the 0 by 2 because time is 2. 5 minus 0 by 2. So 5 by 2, 2.5, which is acceleration. For force, F is equal to MA. M here 10 kg. So 10 A 2.5. So 10 into 2.5, which gives 25 Newton. So option A is correct. Option A is correct. Clear? Clear? If you have any doubt or any question, you can ask me via the chat box. Okay. Option A is correct here. Okay. We will move to the 11th question. Two objects of masses 2 kg, 3 kg, moving at 4 meter per second and 2 meter per second, respectively in opposite direction. Yeah, two objects. One object has mass 2 kg and another object has mass 3 kg. Their velocity 4 meter per second and 2 meter per second, respectively in the opposite direction. Collide elastically. What is the total momentum before collision? Total momentum before collision. Okay, clear. So already you know that the momentum m into v, mass into velocity. So you can assign the directions. 2 kg at 4 meter per second, you can take the positive direction, and 3 kg at 2 meter per second, negative direction, because it travels opposite direction. It travels in the opposite direction. Okay, so we can take that one object as a positive direction, another one object at rest in opposite direction. So negative. Okay, right? So total momentum. So total momentum means you have to multiply the mass into velocity with the directions. Correct? Because momentum is a vector quantity. So total momentum, first of all, m into v. So 2 into 4, 2 into 4 plus 3 into 2. So you have to multiply 3 into minus 2 because it travels in the opposite direction. So negative direction, 3 into minus 2. 2 into 4 gives 8. 3 into minus 2 gives minus 6. Okay, 3 into minus 2 gives minus 6. So 8 minus 6, 2 kilogram meter per second. So this is a unit for momentum. 8 minus 6, 2 kg meter per second. So which is option B is the correct answer. Clear for the 11th question. Okay, 12th question. Already I told you that it's mechanical energy considered in which type of collision? Mechanical energy means which is the summation of kinetic energy and potential energy. So mechanical energy always considered in the elastic collision. Okay, option B, elastic collision. Clear? For the 12th question, option B is correct. Okay. And 13th, the formula for gravitational potential energy, very, very easy one. mgh, mass into acceleration due to gravity into height of the object. The formula for gravitational potential energy is B is equal to mg, guys. So option B is correct. 14th. A 2 kg object is lifted to a height of 5 meters and then released. What is the kinetic energy just before the hitting the ground? Okay, right. So that 2 kg object is lifted to a height. So the potential energy accumulated. Yeah, the potential energy at heights. Already you know that P potential energy is equal to mg hertz. Just know we saw that. Okay. So P is equal to mg hertz. So m 2 g here 10 h height. Here the object lifted to a height of 5 meter. So 2 into 10 into 5, 100 joule. This is the potential energy. Assuming no air resistance. So all, because in this mechanical system, in this conserved system, the mechanical energy conserved. Yeah, already we saw that one animation in that class. Yeah, in that collision conservation of mechanical energy topic. Yeah, so all the potential energy converts into kinetic energy. All the potential energy converts to kinetic energy. So kinetic energy 100 joule, because potential energy 100 joule converted into potential energy, kinetic energy. So for the kinetic energy, we have a formula that is half mv square. But here you don't have a velocity. That's why we cannot find the kinetic energy using the formula of mv square. That's why we find the kinetic energy value from the potential energy equation. So because mgh values are there. Yeah. So that's why for the mechanical system, for this conservation of mechanical energy, potential energy equal to kinetic energy. Because all the kinetic energy converted into potential energy and the potential energy converted into kinetic energy. So kinetic energy 100 joule. Clear? Okay. 15th question. A 1 kg object moving at 6 meters per second collides elastically with a 2 kg object moving at 3 meters per second in the same direction. What is the final velocity of the 1 kg object? Clear? Okay. Already we know that is conservation of momentum in this collision topic. Conservation of momentum means m into v before collision equal to m into v after collision. Yeah. So for the first object, m into v, and for the second object, m into v. So you have to addition those momentum before collision and after collision. So which is equal? Okay. So m into v, m mass 1, d 6. Clear? Plus then 2 kg into 3. Clear? 2 kg into 3. Yes, you can ask me any question regarding these questions. Okay. Via the chat box. So consideration of momentum, m into v, 1 into 6 plus 2 into 3, which gives 1 into v1 dash plus 2 into v2 dash. So here v1 dash and v2 dash is the final velocity. We don't know the value of final velocity. Yeah, so we can put like that, like v1 dash, v2 dash, like that, or you can write some other terms, like some other letter with okay, like for example v before collision u, like that. Okay, so 1 into 6 plus 2 into 3, which gives 12, and 12 v1 dash plus 2 v2 dash. Consideration of kinetic energy, half mv square. Half into mv square. For the first object, half into mv square. 1 into 6 square. For the second object, kinetic energy half into mv square. Half into 2.3 square. 2.3 square. Clear? Okay. So 1 into 6 square here. 1 into 6 square, 36 by 2, 18. Clear? Half into 2.3 square. So 2 into 3 square. So 3 square means 9. 9 into 2, 18. 18 by 2, 9. Okay, this is the moment kinetic energy before the collision. So after the collision, half into m into v1 dash square, half into 2 into v2 dash square. Okay, clear? Okay. So here half into v1 dash square and v2 dash square. Clear? Okay. So in that section here, we can cancel the 2. That's why here only v2 dash square only. Okay, right. So 18 plus 9, 27. 27 equal to 1 by 2 v1 dash square plus v2 dash square. Solving these equations, these two equations, total equal to v1 dash plus 2 v2 dash, and then 27 1 by 2 v1 dash square and v2 dash square. Solving these two equations, we will get the value of our final velocity of the first object, that is 1 kg object. Okay, so that is v1 dash 2 meter per second. You can check that value by solving these two equations. Total equal to v1 dash plus 2 v2 dash and 27 of v1 dash square and v2 dash square. Okay, clear? Okay. 16th question. Kinetic energy is conserved in which type of collision? Already you know that kinetic energy is conserved in which type of collision? Elastic collision. Is it correct? Yes, very good. Option A is correct. Option A is correct. Option B, sorry, question number 17. The coefficient of restriction for an elastic collision. The coefficient of restriction for an elastic collision, option B, 1 is correct. The coefficient of restriction E is equal to 1 for elastic collision. For the elastic collision, coefficient of restriction E is equal to 1. Relative velocity of separation equals the relative velocity of approach. For the elastic collision, the relative velocity of separation equals the relative velocity of approach. So E is equal to 1. E is equal to 1. Clear? Okay. 18th question. A particle is projected with an initial velocity 20 meters per second at an angle of 45 degrees to the horizontal. What is the range? Okay. So range formula R is equal to U square sine 2 theta by G. Yeah, already you know that. U square sine 2 theta by G. U here initial velocity 20 meter per second. So 20 meter per second. Theta angle of 45 degree to the horizontal. So theta is equal to 45 degree. So sine 45, sine 2 into theta. So sine 2 theta. 2 into 45, sine 90. So sine 90 equal to 1. Sine 90 degree equal to 1. Clear? So G is equal to 10 meter per second. Clear? Okay. So formula R is equal to U square. U square means 20 square. Sine 2 theta means sine 90 degree 1 by divided by 10. Clear? So 20 square 400 by 10. 400 by 10 which gives 40. Okay. So range is nothing but distance. Yeah. So we have to mention the SI unit also. So R is equal to 40 meter. 40 meter. This is the answer for that question. 18th question. 40 meter. 19th question. A 4 kg object is moving with velocity of 5 meter per second. What is its kinetic energy? Already we knew about that kinetic energy formula. That is half mv square. So here, very straightforward question only. Yeah. So m 4 kg, v velocity 5. So kinetic energy half into 4 into 5 square. M into v square. 4 into 5 square. So half into 4, we can cancel out 2, which gives 2. 5 square, 25. So K is equal to 2 into 25, which gives 50. 50 joule. kinetic energy 50 joule. Okay. So this is the answer for the 19th question, 50 joule. Option B is correct. 20th question. Two forces of 10 Newton, 15 Newton acts on an object at an angle of 90 degree to each other. What is its magnitude of the resultant force? For the forces at 90 degree, the resultant force formula, resultant R is equal to root of F1 square plus F2 square. Okay. For the forces at 90 degree, F1 square, 10 Newton. So 10 square. Second, F2 square, 15 square. So 15. So 15 square, root of 10 square plus 15 square. 10 square gives 100, 15 square gives 2 to 5, and then 100 plus 2 to 5, 3 to 5. Root of 3 to 5. R is equal to resultant. Okay. So resultant force equal to root of 3 to 5, which gives approximately 18.0.3 Newton. So option C is correct. For the 20th question, option C is correct. 18.0.3 Newton. Okay. So if you have any question, please ask me via the chat box. So today test is over. Any doubt? Any doubt? Any doubt? Okay. Thank you. Thank you so much. We will wind up the class. Jai Bharat, Jai Hind, Jai Vidyasati. Thank you all. Thank you, teacher. Thank you, students.